To learn Cassandra data modeling, let's use a movie domain for a sample application called KillrVideo. KillrVideo is a web application that allows users to create accounts and log in. Once logged into the site, they can search for videos, such as television shows or movies. They can watch them and then respond by adding their own ratings and comments. Some of the challenges that KillrVideo faces as a very successful application include the following. First, it needs to scale to support fast reads and writes even as more users and more content are added. At the same time, users expect the application to be highly available, and the development team wants the application to be easy to manage and maintain. So, how will our data modeling choices affect those outcomes? Currently, KillrVideo stores its data in a relational database. However, the master-slave architecture causes a single point of failure when the database crashes. KillrVideo also found that scaling the relational database is doable but difficult. Users on the other side of the world experience lag on the site simply because of their geographic location. Ideally, the KillrVideo team could store their data in both the Eastern and Western hemispheres so that all users can enjoy a pleasant viewing experience with no lag. KillrVideo plans to migrate to DataStax Enterprise to address these problems. DSE groups nodes in a peer-to-peer fashion rather than a single centralized master-slave database. DSE also scales linearly with the number of nodes KillrVideo adds to the system. DSE is always on because when some nodes fail, the other nodes can pick up the slack. Using DSE, KillrVideo can easily locate its nodes geographically closer to each user's physical location. Now, let's set up our environment so we can begin working on our new Cassandra data model for KillrVideo.